Standard deviation is the square root of variance. So if your variance equals 9, take the square root of that, and now you get 3. And what happens to the squared units? Well, the squared units, if it was 9 squared IQ points and we take the square root of 9, now we say it's 3, and the IQ squared just becomes IQ. So the standard deviation is 3 IQ scores. And that is more comprehensible. We get it. If we look at the formulas, they look very, very similar. But instead of saying, and this is for the population, instead of saying it's the average squared distance, x is to mu, we now say it is just the average distance, x is to mu. All right, and in the formula, what changes is, well, this is the formula for variance. Just take the square root. That's all you have to do. You have to get variance first, then take the square root. Same thing for the sample. All right, the sample is for standard deviation, is the average distance, x is to x bar, the average distance. All right, when we were looking at variance, it just said it is the average squared distance. But standard deviation, or S, is simply the square root of variance. All right, so we'll take the square root of S squared, and that gives us S. So you've learned that S is the most commonly used measure of variability. The reason for that is twofold. It gives us an average. The average distance scores are to the mean, but we had to calculate it a very special way. We had to get variance first and then find the average. You can't dive in and just find the average first, because that brought us back to the mean deviation. Remember, where half of the deviation scores are going to be negative and half will be positive? That is no good. So to calculate standard deviation, you first have to calculate variance and then take the square root of the variance. All right. So we like standard deviation because it is an average, and we like it because it got rid of the problem of having squared units. So this is why Snoopy is doing his little happy dance. Okay. Again, these are definitional formulas because they help to define what's going on. If you were to see this formula, right away, you should recognize it as a parameter. And what gives it away? Well, the mu is a dead giveaway, that Greek symbol, okay? So this is a parameter. And if you were just to look at what's in the brackets, you should say, well, it's summing distances, right? But squaring those distances first, then adding them up and dividing by however many we had, that's an average. But because we squared them first, it's an average squared distance. All right. Same thing is going on here. Average squared distance. The -1, remember, is a little correction you're going to learn about later. And the fact that we're taking the square root means we're getting rid of the squares. So this is standard deviation. So you need to get to the point here where I could call you up at 3 a.m. and say, quick, what does S stand for? And you should be able to tell me standard deviation of the sample. What does sigma squared stand for? And really quick, without hesitation, that's the variance of the population. So you need to know these 4 symbols and what they mean inside and out. So sigma squared, sigma, S squared, and S. Very, very important. Same thing, mu versus x bar. You have to know those on site really, really well. And what is the alternative symbol for x bar? It's the capital italicized M. All right. So I just want to underscore that, because without knowing these symbols and glossary terms and everything else, you're going to have a hard time because we're just learning so much in this class. And so practice using the vocabulary quizzes. Do what you need to do, but make sure you memorize definitions, memorize symbols, and then we'll work on understanding them inside and out, okay? All right, so I think this is a really good place to stop.